Stratasys PC-ABS, industrial grade filament, but how does it compare to the Polymaker PC-ABS printed on Prusa or Bambu Lab printer? Hello, welcome to my tech farm. In this video, I want to compare an industrial filament, this is Stratasys PC-ABS, printed on Stratasys printer, versus a consumer filament, this is Polymaker PC-ABS. Earlier I did something similar with the Bambu Lab ABS printed on Bambu Lab printer, and later with the Prusa ASA printed on Prusa printer. Now Polymaker don't have printers, so maybe these test objects I will print on both machines, obviously on Bambu Lab and on Prusa. And Stratasys, I mentioned that it is printed on Stratasys 3D printer, but I don't have this expensive industrial machine, so I use here a 3D printing services, and I use them from the Varinex company. I paid for these test objects. I'm not sure about the price here, you can see I will check in approximately $10. And until with the previous ABS and ASA filaments, the difference was not big between industrial and consumer filaments, but here I'm expecting some bigger difference because I can see it was a huge difference in the print temperatures. With the Polymaker PC-ABS, the recommended print temperature is between 250 and 270 degrees Celsius. Until that, this Stratasys PC-ABS is printed far above 300 degrees Celsius. I got some footages from the Varinex company, so let's see them. This is the picture of my test objects. They use the raft. With this they are eliminating the elephant foot effect, and they use the supports even for this small bridging above the hole. This is Stratasys Fortus 450 MC. It's printing my test objects, only it is hard to see inside. Let's see some parameters. Printing time will be 10.5 hours, and printing temperature is 325 of PC-ABS, and on the supports 220. And let's see the chamber temperature. It's 95 degrees Celsius. This is the picture from their slicer. It's printed with 100% infill with 0.175mm layer height. A few overall specifications about PC-ABS. It is quite strong industrial filament, and it tries to combine the advantages of these two base materials. And I tested several brands, and I can see that the biggest advantage of this filament is impact resistance. And earlier I had my DIY tester which I use, and almost every time when I try to test PC-ABS, there was no break under my half kilogram hammer. So the impact resistance is very high with these materials. But it is also very hard for printing, and some brands requires even 80 degrees Celsius inside the enclosure, while my maximum is 65 on Bambu Lab and Q2. On Prusa Core One L it is 60 degrees Celsius. I never tried to print this filament on that printer. It will be tested in this video. It's important to mention that this channel is sponsored by Polymaker, but this don't have any effect on my experiments. I mean, they also want real data. Let's take a closer look of these test objects. They're in a black color. 3D printing quality on the Stratasys is great, like with the previous two printing. Also, I think in the slicer they compensate the shrinking. For example, this is 80mm in design, but I'm measuring 80.08, so no shrinking. Actually, it's even a little bit bigger. And there is no elephant foot because they use the raft. And even for this small bridging, they use a support material. Oh, I can see some ghosting. The only issue I have with these test objects is this ghosting. Hardly noticeable, but I'm using artificial light and I could spot it. But except this is perfect printing. I'm using the same test objects like in the previous two videos, so the numbers are comparable with each other. Polymaker PC-ABS is also in black color, and I already have a review video of this filament maybe 2 years ago, and the printing temperature is between 250 and 270 degrees Celsius, and I could print with this material on a 65 degrees Celsius chamber temperature. Drying will be in the HTMS, settings 80 degrees Celsius 8 hours, and it will rotate the spool during the drying. My regular test objects printed with 100% infill. Generic PC is the start profile. 65 will be the chamber temperature, the maximal on this printer. bed 110, and nozzle temperature 280, a little bit higher than maximum recommended. The maximal flow I'm reducing to 8. This is old filament and not designed for high-speed printing. And the cooling I'm reducing, it will be between 0 and 30%, experience from my review video. But of course this minimal layer printing time of 2 seconds is too short. It will be 5. And the printing time will be approximately 4 hours. H2D. And last time when I was printing with this filament, I used the glue on textured PEI sheet, but I'm curious if it will work without glue too. Looks like it will be fine, it passed that critical point. The warping may appear because of the shrinking of the material, but also because of the weaker bed adhesion, but so far it's okay. Bed cooled down completely. This is now Prusa slicer, same test objects. Let's see the settings. On the laser 280, on the bed 110, 60 chamber temperature, flow also 8, and the part cooling between 0 and 30%. And the printing time will be approximately 5 hours. And now moving to the Prusa printer, I really tried to use the same settings. Now I had few attempts and looks like I have to use the glue with this satin sheet. It's on that critical point when the warping may appear, but looks okay so far. It will be finished soon. It's finished, the bed cooled down. It is also surprising to notice that the worst quality is on the Stratasys printer. Bambu and Prusa are similar, except the bridging, it is nicer on the Prusa printer. Quick weight check, Stratasys, 50 grams, Polymaker printed on Prusa, 50 grams, and Polymaker printed on Bambu, a little bit lighter, 48 grams. This is quite big difference, almost 4%, so I decided to do more measurings, but in front of the camera just one, for the tensile test, Stratasys, 2.313, Prusa, 2.310, very close, Bambu Lab, 2.203. Here I collected the printing temperatures and the printing time because it is very different, and it is important to remember this labeling. Here you can see what it means. These are measured values in grams and this is in the percentage, and we can see that the Polymaker printed on Bambu Lab printer is lighter by approximately 5%, and I believe that this will be visible on the measurings too. This difference in weight bothers me so much that I decided to investigate this, and I found the reason. In Bambu Studio, for generic PC, the default settings for the flow ratio is set to 0.94. In Prusa Slicer, the default setting for the material I used is extrusion multiplier, and it is set to 1 correctly. I don't really understand why would anybody set so low default value for the flow ratio. I mean, it's calculated from the geometry. I'm just guessing, so maybe those filaments which are more sensitive to moisture, polycarbonate, nylon, if they are wet, we may have some overextrusion, and maybe they try to compensate this. But actually the correct method would be drying the filament, because we may have weaker parts. But I believe that more users will complain that they have very ugly overextruded parts instead of drying the filament. Maybe they don't even recognize that they have to dry the filament. Anyway, the Bambu Lab test objects will be used as they are, so I'm not reprinting them. I hope at least we will learn something from this testing. And now the shrinking, Stratasys 80.08, Polymaker 79.71, and Bambu Lab 79.49, more shrinking. Now actually, even in the Stratasys versus Prusa ASA, I noticed that the Prusa parts are more dimensionally accurate, and I'm not really sure, is it compensated in the slicer, or maybe the Prusa Core One L is printing these test objects bigger, technical filaments. I will check this soon. I have some carbon fiber reinforced PLA, but that's a subject for the future. These are hooks printed in vertical position. The layer adhesion is important here. Polymaker printed on Prusa. Stratasys. The brake is very similar, only with the bamboo two parts are still connected. One more time reminder for this labeling, and interesting to notice that even if it was printed with some under extrusion, objects printed on Bambu Lab are stronger compared to the Prusa printers. Is this difference in the set temperature, or maybe those 30% part cooling are stronger on Prusa compared to the Bambu Lab? I'm not sure, but this is what I measured. Stratasys is somewhere between, and I'm very curious if we will see the same ratio on the layer adhesion test. Hooks printed in horizontal position. Polymaker PC-ABS still connected with both objects. Stratasys brake was more rigid. So these hooks are printed in horizontal position, and we can clearly see the advantage of the normal extrusion compared to the under extrusion. Polymaker parts printed on Prusa are the strongest, and the Stratasys is somewhere between. Tensile test, slow motion 4 times, side by side all three materials. Three results for the Bambu Lab version, printed on Prusa and Stratasys. Between objects printed on Bambu Lab and Prusa, the rate is very similar, but this time the Stratasys is the weakest. Layer adhesion, objects printed in vertical position, also slow motion video 4 times. Two results for the Bambu Lab version, printed on Prusa and Stratasys. Well, between the objects printed on Bambu Lab and Prusa, the rate is very similar, so even with the under extrusion, the bamboo objects are the strongest, but this time the Stratasys is the weakest. And these are in newtons, but I calculated here the values in the kilograms, and this is my rating for this size of the test objects. Bending test side by side 3 materials, speed up 4 times. And only on Stratasys I could record some break. I could even hear it. The graph and the maximal load. Bending strength and elastic modulus. The bending strength is calculated from the maximal load. Elastic modulus depends from the deformation too, but we can see a small advantage of the normal extrusion. Objects printed on Prusa are a little bit stronger compared to the Bambu Lab objects, and Stratasys is somewhere between in both cases. Izod impact test side by side 3 materials. Results from 3 measurings. Charpy impact test. And again results from 3 measurings. This is important property for these materials, and objects printed on Bambu Lab and Prusa, they have similar toughness, and the most brittle between these three is the Stratasys, but even this is quite tough compared to any other filament type. The elimination hook test, when the weakest will fall out, and at the end we will get the winner. This is the first pulling, slow down 8 times. And the first one which was broken is Stratasys. The second pulling, I think it's visible even now. This is object printed on Bambu Lab. So the winner is object printed on Prusa. The temperature test in the oven, and the only load of this test object will be their own weight, and objects are tilted just to start the diaphragm in the same direction. This thermometer is accurate, but it has some small delay. It is just here for the approximate temperatures. And you will see the order, but actually the difference is not big. But now for the touch, they are very similar. Do you know that the plastic injection molded parts inside the car are usually made from the ABS or nowadays from the PC-ABS because it is more temperature resistant material? That's why I decided to do this creep test inside the car. I already measured them, this is their initial deformation, and I will record the maximal temperature. I'm on my workplace and the temperature will be over 40 degrees Celsius outside, and I will measure these test objects at the end of my workday. I could find some parking place in the shadow too, but only for this experimenting. It will be exposed to the direct sun. We can go home earlier because of the extreme heat. It is 2 p.m, but now let's check the test objects. Let's check the temperature. The maximal was 55.80 degrees Celsius. I thought it would be around 60, but let's measure them. 1699, 1662. And after I remove the load, the permanent deformation is extremely minimal. Now let's analyze these numbers. This is the initial deformation, and this is after 4 hours, the distance between two reference surfaces. And the difference between two in percentage is the creeping, and more or less on the Polymaker filament it is very similar, a little bit smaller printed on Prusa printer, but significantly smaller creeping we can see on the Stratasys, one of the biggest advantages of this filament so far. Just one more printing, S-hook, and the only parameter which will be changed is the flow ratio set to 1, all other numbers will be unchanged. This will be a very short, a little bit more than 20-minute printing. This hook is printed on Bambu Lab printer with the 1.0 flow rate, 14.16 grams, and now it has very similar weight like object printed on Prusa printer. And now the break load is very similar to the Prusa printing. There are several conclusions here. One of them is print your objects with the correct flow rate. I'm not really sure why is this value set below 1. I mean, the geometry is very simple. On one side we have the diameter of the filament and the length. On the other side, after extrusion, we have the line height, width, and the length of that line, and these two volumes should be equal. And if this flow ratio is set below 1, in that case we are on purpose extruding less filament. I mean, something is wrong here in my opinion. Maybe you can help me out, because for example, I'm not sure in my future testings should I use those generic profiles which have this flow ratio below 1, or I should continue using those generic profiles without any modification. For those who print functional parts too, it is important to know how to check the flow ratio, and I want to do some research and create a separate video about this. Looks like there are two methods. One is measuring the wall thickness and the other is measuring the weight, but here we have to know the density of the filament and the mass of the individual object. But as I mentioned, it is a subject for a separate video. Probably it will be one of those where I will lose subscribers, but I need this for myself too. And between Stratasys and Polymaker PC-ABS filaments, I think the difference is almost negligible, and I cannot really see the justifying of the higher price of Stratasys PC-ABS, except maybe a higher temperature resistance. Earlier with the printing of the ABS and ASA, I could see improvement in the print quality, and something happened here, I'm not really sure, because earlier the Stratasys print quality was fantastic, and here I could see that ghosting. So this was my short experience with these two filament types and printings on two different printers. If you have some other comments, or maybe you can explain me this flow ratio or extrusion multiplier, few lines down in the comment section. Thank you for watching this video to the end, and as always, happy printing!